Energy transferring and transforming.
Before we do anything about renewable energies, you must understand the difference between energy transferring and energy transforming. Okay. Now, let me give you an example of energy transferring first. So, on a hot summer day, okay, if I have an ice apple here, now what's happen? The, the ice would melt, right? The ice apple would melt. But what's happened is we have an ice apple and it's surrounded by hot air. Okay? So in this case, uh, what I can say is the energy has been transferred, okay, from heat to from air to the uh, to the to the ice. So this is an example of transferring. Now, let me show you another example of transforming, and you can think about it. And maybe I believe you guys are very smart, and maybe well, I think you can just figure it out what is transforming. Now, what's happened is I have a kettle. I have an electrical kettle. So when I switch it on, okay, the kettle actually the electrical energy is being transformed into heat energy to the water inside. Okay, so this is called transforming because before that the form of energy is in electrical form. So electrical form of energy has been transformed into heat form. So we call that energy transferring. Sorry, energy transforming. So if you look at the difference between transferring and transforming, it's basically the form of energy. Okay? So in this case, before the energy is in air, in the hot air around the ice. Then the energy has been transferred to the ice in the form of heat, and the ice absorb it in the form of heat. So the energy is always, whether it's in air or whether it's in the ice, the energy is always in the form of heat. So we call that energy transferring. So in the kettle case, in this case down here, before was the energy was in electrical form. Okay? The electrical kettle absorbs electrical energy from the power point. Then is then the energy got transformed into heat. So that's the difference. That's called transforming. Okay. Now, uh, so the idea to do this is try to come up with a list of different forms of energy. There's a lot of confusion about it. Okay, so let's now think about this and well let me do a list. Okay, so this list is not a final. There's a plenty. There are perhaps hundreds of different forms of energy in the universe. Okay, and I just write down some obvious ones. Um, the first obvious one comes up will be mechanical energy. So if you're running around with your leg or in your car, that's basically mechanical energy. Okay. Um, yes. Well, if you do it in detail, we have different type of different forms of mechanical energy either, but uh, just call it mechanical energy now. So the other energy, well, yes, we have heat. Okay, we mentioned that before, heat energy. Also, the other one I can come up will be light energy, but we don't call it light. So the idea is if I'm walking on a sunny day, okay, the light shines on me and I feel I'm happy. Then the energy came from the sun is in the form of radiation. Yes, well, yes, it's the same thing. I know some of you may thinking about nuclear radiation, but it's the same thing. It's the energy. Um, Energy comes from the sun. It's the energy come from radiation. The light is a yeah. Uh, so light energy is basically radiation energy. Also, if you have nuclear radiations, they're all radiation energy. It means um, energy has been transferred to you, and energy has been transformed to you or transferred to you through something, through non-contact. Okay? So um, if the sun is shining, well, if I sit down on the sunshine, uh, I absorb energy from the sun, okay, but the sun doesn't really touch me. It the energy has been because the energy the sun released is in the form of radiation, and I absorb those radiation. And yep. Also, this basically solar energy is in the form of radiation. Uh, Wind energy, yeah, is in mechanical energy because it's basically the mechanical. When wind blows, it's basically the air particle moves. It's a mechanical, it's a kinetic energy, mechanical energy of the air particle that moves in the air that causes the wind. If we talk about, also we have something called potential energy. Is it comes up with releasing something from higher altitude. Sorry. For instance, if waterfall, if there's a cliff, there's a cliff, and water is running down from the cliff. Yeah, water here running down from the cliff. Now, compare compare the speed of the water on the top and the speed of water on the bottom. Of course, on the top is slower, on the bottom is much higher. Okay. So this is due to the release of the energy as it well as the say as the water drops down. Okay, it becomes faster, 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 and faster. Okay, the further it travels down, the faster it is. Okay, so what's happen? What we mean by potential energy is it's the energy that's in the water. Okay, potential. I made a spelling mistake here. So the energy when the water is on the top level, okay, the energy is in the water. It doesn't get released. Say if the water is here compared with the water to here, well they travel at the same speed, and they have the same energy, same level of energy level. So when it drops down, it becomes faster and faster. That means it has more energy, but where does those energy come from? Okay. So the scientists believe that the energy has been held in those water particles on the top. Once it drops down, the energy got released. So we call those energy being holding in a object potential energy. Okay. So that's the basic concept of water dam. Okay. So yeah, by the basically electricity can be generated by installing a turbine here and just do that. Okay, so because of the potential energy. Okay, the other form of energy will be electrical energy. This is obvious. It's in your battery, it's in your computer. We use electricity a lot. Yes, if I go down the list, there will be millions, maybe hundreds of more different forms of energy. But the main thing is, okay, we talked about that before. You should all know this before. Energy is basically measured in joules. Okay. 1 joule of energy is basically when you lifting an apple 1 meter above the ground. It's it's basically a measurement of 1 joule of energy. Okay, now have a look at this example here. Okay, sorry for the drawing, okay, but I try to do the best I could. So this is a simulation of how ancient people, okay, 2,000 years ago, how does ancient people cook? Okay, so somehow they hunt, well, somehow they hunt a piece of meat. Okay, they get some fire. Sorry, they gather some wood. Okay, they set the wood on fire. They put a big pot. Okay, they put a big pot on the fire. Okay. Then they put some water in, then they put the meat in the water. They try to boil the water. Okay. Now, let me just describe the energy transferring and the energy transformation in this process. Now, initially, the energy is in the wood. So we call those the chemical energy, chemical potential energy, but I just write down potential energy here. Because the energy, potential is a general word. So the idea was the energy is in the or you can call it chemical energy. The energy is in the wood. It's in the structure of the wood. Once we burn it, it releases energy and it turns to the ashes. Okay? So if I don't lead up the wood, the energy is still going to be in the wood. It's just potentially hot inside. Because some people, you also can call it is scientifically correct if you call it chemical energy. Okay? So potential energy in the wood. That's what we started with. Okay. Then this energy, I lead the fire using wood. Then this energy is transformed into heat. Okay. Because of the fire. Okay. Now, then the heat energy somehow transferred to the pot. The pot become hotter. The temperature of the pot increases. So then this is this part is transferring. Okay, transfer. This part is transformed. Okay, sorry, just let me write it down. Okay, the previous part from wood to heat is transformed. Before this potential energy, then its form changed to heat energy. Then it's transferred from the fire. The heat energy has been transferred to the pot. Okay. Then again, the heat energy has been transferred to the water. So it's still heat energy. Okay. Nothing changes. Then the heat energy has been transferred to the meat. Okay. Then after a while it's well cooked, our ancestors can eat it for dinner. So I call it. Yep. Yep. So the idea for this is, as year 11 physics students, you need to be able to describe how does the energy transferred or transformed in your process. Yep. So for instance, if you have, say, if you have a power station, right? In a power station, say if in the power station we use coils. Okay? So step one, the energy in the coil must the chemical potential energy in the coil has to be in the coil. Let me use different color. Well, let me start a new page for this. Okay? So in a power plant, okay? Power plant. Okay. Now let's start with coil. Okay? The energy inside is potential energy or chemical energy. And those energy has been burned up with the fire, okay, release into basically heat form in heat energy. Okay, so this process is uh, transforming because the form of energy changed. Then the heat energy normally they go to they use water. Depends on the type of engine. I'm not really sure, but I assume they use steam engines. So yeah, let's say it's transferred into water. Okay? But it's still the form of energy is still in heat. Sorry. They try to boil the water, and from the boiled gas, the heat energy is then transformed into mechanical energy in the turbine. Then the mechanical energy in the turbine finally transformed into electrical energy. Okay, so yeah, so this is transfer on the top, transform here, and transform because the form of energy changed. Okay? You don't have to know at this stage. Okay, as a year 11 physics students, you don't have to know how exactly does energy transformed from heat to mechanical. Then how does the mechanical transformed into electrical? That's basically we're learning this part in year 12. How do we generate electricity? Well, just the idea for year 11, you have to be able to explain what's happened in a power plant. If I show you a diagram, like the previous page, if I show you a diagram something like this, you need to explain to me how does the energy transferred or transformed in different form or in different stage to the final product. Okay, you need to be able to describe this.